Welcome, class, to our first digital learning day. As you know, we closed out last week with our Unit 9 test, and so this week we are going to start our last unit of the year. This unit is on statistics. So today will be our intro to the unit, and we will talk about different ways that we display data. Today's I can statement is I can choose the best display for data. So we're going to go through various different ways that we can display data and why some types are more appropriate for types of data than other types. Please take note on each of the bolded and underlined headings. I'll go through and highlight them like I just did bar graph as we go through them. And of course, I will have these notes available on eClass for you to use and refer to for studying, to complete practice. So a lot of this is going to be review, and a lot of this we've seen before, but feel free to pause it if we're going fast and you need a second to catch up on the notes. So we'll be talking about bar graphs. Bar graphs display data using horizontal or vertical bars. They best display data that's organized into categories and not data that makes up a part of a whole. When you have data that's continuous and makes up a whole, such as a person's height, it's better to use a histogram. A histogram is more appropriate in that situation. The main difference between bar graphs and histograms visually is that bar graphs will have gaps and histograms will have no gaps. Bar graphs represent different categories, so we want to know that they're separate. That's why they have gaps. Histograms, it's continuous data, and so it actually makes more sense to have them touching, don't you think? But we'll talk more about histograms in that section later on in this video. Next, we have double bar graphs. So double bar graphs. A double bar graph is used to display two sets of data at the same time. They're especially useful when we need to compare data. For example, if we look at our model here, it says sports attendance at State College, and it compares the attendance of football games to the attendance of basketball games for the years 2000 through 2005. And it looks like more people attended football games throughout those years, every single year actually. So maybe this is data from UGA. I know more people go to their football games than basketball. But our main point here is that double bar graphs are very good for comparing data. Next, we have stem and leaf plots. This is one of my favorites because it allows you to see each and every data value. Every single data point is right there in front of you, and that's something that's unique to stem and leaf plots. So they divide each data value into two parts. In our example here, our key tells us that 6 on the stem side and 3 on the leaf side equals 63 years old. Knowing that, I know that if I look at the fours row, that we're talking about ages, and that there are 4 people in their 40s, one that was 40, one that was 44, one that was 48, and one that was 49, all that participated in this survey. They were each 40, 44, 48, and 49 years old. So I took a short survey of some of my relatives that I spoke to over this weekend of their age. And I'm going to list them here, and we can plot them on our very own stem and leaf plot. 56, 66, 59, 72, 80, and 90, and 91. Let's zoom in here. So to plot these data, look at the 50s. I have a 56 and a 59, so put them in least to greatest, 6, 9. I can cross those off now. What about in my 60s? I have 1, 66. I can now cross that off. In my 70s, just 1, 72. And the 80 is just 180, so put a 0 for the ones place. And 91. There we go. We've completed a stem and leaf plot for my data. So next, we would need to remember to put a key. So our key, 5, 6 equals 56 years old. Moving forward into frequency tables. So frequency tables show the frequency of data broken into intervals. The frequency of a data value is the number of times that it occurs. Frequency tables always have equal intervals. So let's look to our example here. Our intervals are listed here, broken into 4 intervals, each one containing 10 values, 1 through 10, 11 through 20, 21 through 30, and 31 through 40. It is in fact broken into equal intervals. And displays the frequency. So, the number of people that enrolled 1 to 10 was 1. The frequency of people enrolling 11 to 20 classes was 4. The people enrolling in 21 to 30 Western Civ classes was 5, and so on. Next, we have histograms. We talked about these a little bit earlier during bar graphs. So a histogram is a type of bar graph used to display the frequency of data divided into equal intervals. Because of this, it's often used to display data from a frequency table. That's exactly what we've done here. This table is the same as this graph. So, the number that enrolled between 1 and 10 was 1, 1, 11 and 20, 4, 4, and so on. It's important to remember that the bars must be of equal width because each interval is equal and should touch but not overlap. Remember, no gaps. We leave gaps in bar graphs because they're different categories, but these represent intervals. And so we leave no gaps. Next, we move on to what may be the most familiar of them all, the measures of central tendency. That's right, I'm talking about the mean, the median, and the mode of the data. Of course, the mean is the average, or the sum of all the values divided by the number of values. The median, of course, is the middle value in a list of numbers when written from least to greatest. That's an important piece. We can't forget to put the data in order from least to greatest before finding the median. And last, we have the mode, which is the number that occurs most often in a list of values. Our last measure is the range, also known as the spread, which is the difference between the lowest and highest values. We should be familiar with most of these from grades prior. And right here, I have a link to a song that talks about the mean, median, and mode and range, all the measures of central tendency, and is really funny and helps me remember how to find each one. So check that out if you have the time. Next, we have box and whisker plots. So a box and whisker plot can be used to show how values in a data set are distributed or how they are spread out. It uses a 5-number summary to display this data. The 5-number summary can be broken down into 5 sections. So the first section is the minimum, or the smallest number in the data set. This number ends the whisker to the left side. Next, we have the lower quartile, also known as Q1. This section begins our box and is the left wall of our box and our box and whisker. The third value is one of our measures of central tendency, the median. The fourth is the upper quartile, also known as Q3. This ends our box and a box and whisker plot. And last, we have the maximum. This is the greatest value in the data set, and it ends our whisker on the right side. Something that may be new this year is the interquartile range, or the IQR, which is the difference between the upper quartile and the lower quartile. This represents the middle range, the range of the middle half of the data. It's actually represented on a box and whisker plot by the box itself, the entire box. And the formula we use to find the interquartile range is Q3 minus Q1. Remember, that word difference means subtract. So we will talk more about box and whisker plots when we go over how we can use our technology to actually calculate these 5-number breakdowns. We'll have a whole day on that later this week. Next, we have box plots. So a box plot is a representation that's used to show frequency. It uses a number line and X's or boxes. Something that is very useful about this information is that it can show you the spread or the distribution of data. We're going to spend a whole day just talking about the spread or distribution and how seeing shapes like this in the frequency of the data can be very useful. Very, very useful for distribution. We'll get more into that as we explore deeper in this unit. Next, we have line graphs. We should be pretty familiar with these from our linear functions, exponential function, and quadratic function units. All of our function units have used the line graphs. And line graphs are used to display continuous data. Right? Line graphs can be useful in predicting future events. It's very important to think about what's happening over time when selecting to use a line graph. They do really good showing what's happening with data over time. Last, we have circle graphs. So circle graphs are used to show the relationship of the parts to a whole. Because it's the part to whole relationship, it's very easy to see percentages when broken down this way. For example, we have grade level of U.S. students. It tells us that 45% of the students go to grades 1 through 8. 12% of students are in kindergarten or nursery school. 15% are in college, and 22% are in high school. So it would be fair to say that 12 out of every 100 students in school go to kindergarten or nursery school. So moving forward, guys, and we are going to have to take a look at our practice activity for the day. So if you go on eClass and you go to the second portion of the checklist, it will provide you with a link to this Khan Academy page. I want you to scroll down a little bit, and when you get to the part that says your turn, you know that you're there. It will show you essay grades and ask you which one of these bar graphs represents this data. Well, I noticed that the data is decreasing as the grade goes from A to B to C to D. So I need to look for which graph is decreasing the entire time. And it looks like only graph C is. Now, does it match 12 A's, 8 B's? Let's see if those two match. 12 A's, 8 B's. That matches. And then 4 C's and 2. Yep, so we know C is our answer. So select C and come down here and hit check. And it will tell you if you're right and give you an explanation. The next one. Student notices that the more months that a cell phone model has been out, the lower its price gets. Which one of these graphs would best represent that cell phone over time? Notice we're talking about time, and it's using line graphs. Which one seems to show that it's going to decrease over time? I think it wants us to look for a negative slope, guys. So just go through these, and there's only 4 questions. It shouldn't take too long. And when you're finished with these, you can go to the last portion on